Number 9, the series n equals 1 to infinity of the quantity -2 to the n plus 1 over 3 to the n minus 1. And we're going to determine if this is absolutely, conditionally, or divergent. So we're looking at the type of convergence here. So we'll start out with our absolutely convergence. I'm going to take the absolute value of this -2 to the n plus 1 over 3 to the n minus 1. That'll give me this series of 2 to the n plus 1 over 3 to the n minus 1. Okay. And now I'm going to do a little bit of algebra here. So I have the series of 2 to the n, 2 to the first, over 3 to the n, 3 to the negative 1. Okay. So that this 2 is a constant that can come out in front. This 3 to the negative 1 is really a 3 that's going to pop up into the numerator. It can also come out in front. So what I really have is a 6 as a constant out in front. There's a series of 2/3 to the n. So this is a geometric series. And the absolute value of r is equal to 2/3. And I know it's geometric because I have a number raised to the n. Okay, so the absolute value of r is 2/3, which is less than 1, which means that this is a convergent geometric series. And since this absolute value version converged, that means that this original series is absolutely convergent, and I'm done. All right, so there we go. There's an absolutely convergent series. And then let's take a look at number 10. So I have the series n equals 1 to infinity of -3n squared over 4 plus n squared. So again, we'll start out with the absolute value version for absolute convergence. Okay, so the series of the absolute value of -3n squared over 4 plus n squared. So that gives me the series of 3n squared, so I got rid of that minus, over 4 plus n squared. So this will always be positive over this domain from 1 to infinity. Okay, and then I need to apply a test to see if this converges or diverges. So this is not a geometric or a p-series, but I can try the divergence test on here, and eyeballing it, it looks like it's going to fail that divergence test. So let's try that. The limit is n goes to infinity of 3n squared over 4 plus n squared. Okay, that is going to be 3. That's not equal to 0. So this diverges by dt. So it is not absolutely convergent. All right, so let's try for conditional. See if we can get that. So under conditional convergence, I'll keep my original series, so -3n squared over 4 plus n squared. Again, not geometric and not a p-series. And I bet you it's going to fail this divergence test. So I have the limit as n goes to infinity of -3n squared over 4 plus n squared, which is -3, and that's not 0. So this diverges by dt. Okay, so overall this thing diverges. We can't get conditional or absolute convergence, either one out of this. Okay. There are other tests you probably could have used on this, like a comparison test, either the direct or limit comparison test, and that would have been fine as well. As long as you apply all the rules and you make sure that you've met the criteria to use a conclusion.